Well, okay, students, I don't seem to be getting a response from y'all, but I think y'all need to take it a little more seriously. Anyways, talking about the second problem, what we had was, as I explained to you all, the diagram. So we've worked with the diagram. Now what we need to do is work with the limits. Okay, so if you have to work with the limits, the first thing we'll have to do is, since we are dealing with a cylinder and we are dealing with a plane, so z equal to 3 and you have z equal to 0 and you have this cylinder. Okay, so since we're dealing with the cylinder and planes, what we'll do is we will adopt cylindrical coordinates. So for volume, basically, if I was dealing with volume, it would have just been triple integration dz r dr d theta. But what we have over here is we have triple integration of square root of x square plus y square. Now in cylindrical coordinates, x square plus y square is r square, and square root of that would simply become r. So that's what you have here. You see an r here. Okay, so what we are going to do is change everything to cylindrical coordinates. So triple integration of r, your dz, dx, dy will change to dz, r, dr, d theta. So now we want the limits on z. To get the limits on z, what we do is we shoot an arrow in the z direction. Now, when I shoot an arrow in the z direction, obviously, it will hit the bottom of the cylinder at z equal to 0 and hit at the top of the cylinder, which is being covered by z equal to 3. So z will go from 0 to 3. So to get the limits on z is not a problem. Now what we need to do is we project this whole solid onto the xy plane. And when we project it onto the xy plane, it's very obvious that we're going to get the cylinder is going to collapse onto a circle. And that's what you get. You'll get a circle seated on the x-axis. So you have a circle seated on the x-axis. Now, if you all remember what you'll have done in in curve tracing, the circle that we have here, the equation of the circle is x minus 1 the whole square plus y square is equal to 1. In 3D, this was a cylinder. In 2D, this is a circle. So I replace x and y by r cos theta and r sin theta respectively. Or rather, instead of doing that, we expand x minus 1 the whole square plus y square to get x square minus 2x plus y square plus 1 equal to 1. You will end up getting x square plus y square equal to 2x. From this, you get r equal to 2 cos theta. So this circle is actually r equal to 2 cos theta. And we have learned that this whole circle gets completed from 0 up to pi. So to get the limits on r and theta, what we need to do is we need to stand at the origin. From the origin, we shoot an arrow into the region. So r will start at 0 and come out at the circumference of the circle, and that becomes r equal to 2 cos theta. So r goes from 0 to 2 cos theta. Now the question is, what will theta go from? Theta will go from 0 till pi, because the whole circle gets completed from 0 to pi. So these are your limits of integration. If there's any further query that you have with regards to the problem, you can let me know.